If, then, else. Hello everybody, this is Ben Finkel, and in this nugget, we're going to take a look at the conditional statement inside of Python, more commonly known as if, then, else statements. Almost every language has some variation of this. It's an important logical clause inside of programming, and it allows you to set up multiple blocks of code that may or may not be executed depending on the state of your program or the context that it's running in, the value of a variable. So it's a really important logical structure inside of any programming language. Python is no different. To begin with in this nugget, we're going to talk about expressions and statements to start off. These are a couple of important vocabulary words that apply very expressly to if, then, else statements. Then we'll take a look at some of the logical operators that we're going to use in our if statement, and this is things like greater than or less than and equal to and not equal to. We'll move into some code and we'll actually write an if statement. We'll see how it works and how we can adjust our flow of our program depending on the input that we get from the user. And as part of that, we're going to talk a little bit about statement blocks in Python and how you use indentation in Python to define statement blocks as opposed to parens or curly braces or the things that they use in a lot of other programming languages. All right, let's get started. So what happens to all of us? Our computer program is chugging along just fine, running its different statements 1, 2, 3 down the line, and then we get to a point where we need to make a decision. Maybe it's a gateway into a more advanced part of the program. We need to make sure that you have the admin password before you can continue into this advanced portion of the program. And if you don't have the password, then you need to be redirected to a different portion of the program. This is called a conditional in programming. Remember, computers are logically malleable. Malleable means that they can be changed and moved around, like, say, Play-Doh is malleable. Well, computers are logically malleable. They may be physically made of plastic and metal and they can't change, but internally they can make a lot of decisions about what they should do based on the internal state of the program, based on what's in memory, what's been keyed in, what the user has clicked on, or what the user wants to do. The basic logical structure here is a conditional, also known as an if, then, else statement. Now, before we go any further, I want to stop and take a moment to have another quick vocabulary lesson. And yes, I apologize. I know that no one likes vocabulary, but as I hammer home time and time again over this video series, vocab is really important when we're doing programming. Computers are dumb. They're going to interpret everything we say exactly the way we say it. So we need to take care and know what kind of words and language we're using, not only when we write our programs and interact with the computer, but when we're talking about our programs and talking about how we're going to write these programs. So specifically, we want to take a look at two different words, expressions and statements. And these are important. Frequently, you'll see them used interchangeably when people are talking about programs, but they're not interchangeable. They really have two different definitions, and they come up a lot in documentation for programming. So, for instance, when you look at the documentation for an if statement, you might see if expression, then statement, else if expression, then statement, and so on and so forth. And expressions and statements really perform two different functions. Now, there's no hard and fast rule about what they mean, but generally speaking, here's what you can assume about these two things. An expression almost always evaluates to a value. So it becomes a true or a false or a number or a string or something else. An expression is not a standalone programming statement. Rather, it's a part of a statement that in turn can be reduced down to a single value. In our if statement, it's going to be reduced down to what's called a Boolean value, which can be true or false. Statements, on the other hand, are full, complete sentences inside of our programming language. And a full sentence means that it may contain expressions, it may not, but it can stand on its own. It will execute entirely on its own, in theory, as part of our computer program. So when we talk about the if, then, else structure, what we're saying is that we have to run if, or key in the word if, and then have an expression that's going to evaluate to either true or false. And if that expression evaluates to true, then we're going to run some kind of statement. If that expression evaluates to false, then we're going to run some kind of other statement. And inherent in all this is that actually this entire block, this entire piece of code, is also a statement, the if statement, in fact. So statements are not only single lines or single individual things, they can also be blocks or groups of expressions, statements, etc. that perform a function, that perform an operation inside of your program. So Expressions and statements. Typically, expressions are smaller portions of statements. They evaluate to a single value, and they do not run on their own. They do not exist without the support of the rest of the statement. Statements are things that execute or are entirely modular and can run entirely by themselves. Put that in your back pocket and remember that, particularly when you're looking at documentation for different programming languages, Python or otherwise, you're going to see expression and statement probably used a fair amount. Now, all that is nice theory to talk about, but what does it mean? How do we write an expression? We already know how to write statements, right? That's what we've been writing all along. Print statements and input statements and even variable assignments. When we put a value into a variable, that's a statement inside of our program. But what about expressions? We haven't really written any expressions yet. And although we just haven't realized it. We haven't focused on them very specifically. Now we very explicitly need to write an expression. We need to formulate the expression portion of our if statement. And to do that, we're going to use some more new operators. Remember, operators are like an equal sign, which is the assignment operator. That puts a value from the right-hand side of the equal into the variable on the left-hand side of the equal. Or a plus or a multiplication that takes two values and returns the result of multiplying or adding those two values together. Well, we are going to use the Boolean operators. And they are equals, not equals, greater than, and less than. And they work exactly like they sound like they're going to work. If we take something like the greater than symbol here, then what this is going to do is it's going to look at the value on the left and the value on the right, and if the value on the left is greater than the value on the right, it'll return true, and if it's not, it'll return a false. There's a Boolean value inside of our programming language. That's how we can get our if statement to function. We have an expression that has the potential to return two different values. That means that if it's true, we can run one statement. If it's false, we can run a different statement. So we're going to learn about those new operators. Let's take a look at some code now and start executing some of these things to see how it works. I'm going to begin with showing off a few of those expressions that I just finished talking about, and I'm going to do that in the Python interactive mode command prompt. So notice the three triple arrows. I'm now in Python interactive mode. And let's start off with just 5 greater than 10, which is, of course, a false statement. When I hit enter, it returns false. So the expression 5 greater than 10 resolved to the value of false. And true and false are what are called Boolean values inside of the computer programming world. Now, you might be thinking, hey, that's an expression, not a statement. I thought we couldn't execute expressions. We can only execute statements. Expressions can be part of statements, but it has to be a statement. Well, when we're in interactive mode, there are certain assumptions going on here, and in this case, the print function is assumed. I could also have just done this and explicitly stated my print statement, would have returned the same thing. So interactive mode kind of knew that what I wanted was to output that value, and it output it for me, and that's why I was able to see it. And of course, that's how the greater than statement works. It tests the expression, and it returns a value, true or false, based on whether or not the expression you've built is in fact true or false. If I said 10 is equal to 10, that returns true. If I said 10 is not equal to 10, that returns false. Is 10 less than 20? That returns true. So on and so forth. You get the point. These little expressions evaluate to either true or false. They can only evaluate to one or the other if they're going to work inside of an if statement. One little point that trips up a lot of developers is in some languages the comparison operator, the equal sign, is not a double equal sign, but it's actually a single equal sign. It's 10 equals 10. And the programming language, the compiler, uses the context that it's being used in to determine which one it is. Well, that's not true in Python. A single equal sign is the assignment operator, and if you do that, you're going to get an error. You see it here. I can't assign to a literal. So it's always got to be a double equal when you want to use it in an if statement and test the truth of the statement. A single equal is the assignment when you want to assign a value into a variable. So now let's start building out a bigger program and see how our if statement works. Alright, I've got my first example program up on screen, and let's see it in action first. It's a little bouncer program. It's only going to let you into this cool nightclub if you're older than 20 years. So I'm going to go ahead and run my program. Oops, 1.py. And the first thing it asks for my name, well, my name is Benjamin. And my age is 35, and it says, Benjamin, you're older than 20 years old. Hey, that's true. I am older than 20 years old. All right, I'm allowed in the club. If I go ahead and run it again, I'll type in my name again, and this time I'll lie and I'll say I'm actually 19. It says, unfortunately, Benjamin, you are younger than 20. That means I'm not allowed in. Darn. All right, let's take a look at this quick little program and see how the if then else statement works in Python. To begin with, I'm collecting the name and the age from the user right here at the top of my program. And if you're wondering what I'm doing with the age variable there, notice that I'm collecting it as raw input into raw age, and then I'm turning it into an integer with the int function, and that's going to help me support good error handling later when we introduce error handling into our programs. Now below that, I've got my if statement, and it breaks down pretty simply. I think it's relatively easy to understand, even if you're new to programming. We have the word if, that's a keyword. Then we have age greater than 20. That's our expression that we talked about. And then a colon sign. Below that is a statement. That's actually our true statement. That's what's going to execute if the expression evaluates to true. Then I've got another keyword, else, another colon. Those are important on each clause in our if statement. And another statement. And that's what's going to evaluate, or that's what's going to execute if our expression evaluates to false. So the syntax here is if expression colon true, else colon false. So if this expression evaluates to true, we run our first statement, and if it evaluates to false, we're going to run our second statement. So now that we understand what's going on, let's run it one more time, and I'm going to do something a little tricky. I'm going to tell my name is Benjamin. Now what happens if I key in my name as being 20? Well, 20 is not greater than 20, and it's going to say, unfortunately, you are younger than 20. Now, maybe that's your desired expected behavior, but maybe it isn't. Based on the way we've written this up, that's not exactly what we wanted. 20-year-old people should be allowed into our club. So we need to use a slightly different comparator in our expression up here. It's going to be greater than or equal to. And that's what that expression, or that's what that operator means, greater than or equal to 20. If I go ahead and do that, save it, rerun it, and type in my name, and my age is 20. Now 20 is not greater than, but it is equal to, and so it says, hey, you are older than 20 years old. I should probably also change that text to say you are at least 20 years old. Would make sense. And we can use any of the operators in here in between our two operands in this expression. We can say if age is not equal to 20. What does that mean? That means it's only going to let me in if I'm not 20 years old. So I'll just go ahead and say, change the text here to say you are allowed in. Unfortunately, you are not allowed in, period. Save that. So here I've said that if age is not equal to 20, then allow me in. So this club is now going to allow only people in who are not exactly 20 years old. If I run it, unfortunately, I'm not allowed in because I said my name was 20. Again, I can run it here, make myself 21. Now I'm allowed in because 21 is not equal to 20. That evaluated to true, so the first statement in our if block ran. Now there's one additional feature of Python syntax. It's actually baked into this if statement that we haven't gone over yet, and that's because it's not exactly obvious what we've done, but it's real important. It's a real important feature of Python, and we need to know about it. So you may have noticed that the two statements that evaluate on true or false, or that execute on true or false, are indented a little bit from the if and the else. And that's with good reason. For starters, it's a typical programming form to do. It really makes it a lot easier to read your code when you indent statements like this. After all, if I line them up along the left edge like this, you can see it's already a little uglier, a little more difficult to read. If I took out these blank lines, got rid of my white space, it's even more difficult to read. So good use of white space is important for making your code legible. Well, in Python, it's also important for syntax reasons. The indentation actually groups statements together into statement blocks. So let's change up my code a little bit here. I'm going to go back to greater than or equal to 20 because I think that makes more sense. And what if I wanted to execute more than one statement when this if clause was true? I could go down here and I could write a whole other if clause and do my second statement. But what if I wanted to write 3 or 10 or 20 different lines of code that all evaluated when my if question was true? Well, the best thing that I could do is to simply create a block of statements here and say both of these are going to execute when the expression evaluates to true. So these are all of the statements that are going to execute, and I could have as many statements as I wanted inside of this block. All execute when my expression evaluates to true. And the way that Python knows they're all grouped together is once again because they're all indented to the same length. And this is contrary to almost any other programming language out there, which usually has you wrap statements like this inside of curly braces or inside of parentheses in order to indicate that they're grouped together. Python doesn't do that. It gets rid of those extra characters. It figures you don't need them. You want to indent your code anyway to make it more readable. So the indentation actually indicates what code belongs to what. So as Python's executing through this, and we'll go ahead and see this run now. Let's give it a run. My name is Benjamin, and my age is 21. And you can see it's allowed in, and then it asked me what would I like to drink. So both of those statements executed when age was in fact greater than 20. And really quickly, just to demonstrate, if I'm 19, only the false statement executes when I'm 19. So again, the indentation here is really important. And there's no set standard for what the indentation has to be. I've used the tab character, which gets me about 4 spaces. But you could use regular spaces as well. I could just put 2 spaces here in between the left margin and my statements. And that's fine as long as you are consistent about it. The consistency of that indentation is what's important. So that's a nice feature of Python. It allows the code to be a little simpler, a little more terse, and a little more legible as compared to a lot of other languages that include lots of obscure characters, curly braces and brackets and that kind of thing, that often make things more difficult to read. This is nice and easy and clean to read, and it encourages you to use good indentation practices, which makes your code easier to read anyways. Now I'd like to show off one more feature of the if statement, and that's something called elif, which is short for else if. And essentially it allows you to have multiple expressions tested inside of a single else statement. I'm going to adjust my code here and show you what I mean. You can see now I've added this block of code, this elif, right below my if clause, but above my else clause. And that's important. Else always has to be the last, the final clause inside of any if statement. And this elif looks exactly like the if above it, except it tests a different test. It says if the age is greater than or equal to 18. So now I've turned my club into an over-under club. If you're 18 or older, you're allowed in, but you're not allowed to drink. And I updated my top clause to say if you're 21, you're allowed in and you'd like to drink. 21's the drinking age, I think, right? So now what you have is you've got a statement that can execute multiple expressions and operate differently depending on which of those expressions are true and false. And there's still a procedural programming language, so it's going to move down the line here, and if it hits one of these clauses, if it hits this first clause, it's not going to run the second clause. If it passes the first clause, it'll execute the second clause. If it passes that second clause, it'll execute the third clause, if there's a third clause, right on down the line. So you can create multiple catch points for your logical expressions inside of a single if statement. Let's see this guy in action now. Go ahead and make sure it's saved. Run my code, type in my name, and I'll start with saying that I am in fact 21. And it says I'm allowed in and I'm allowed to have a drink if I'd like. Now if I run it again and say I'm only 19, you can see it's allowing me in, but I'm not allowed to drink. So it hit the second clause on that if statement. And then lastly, of course, just like before, if neither of those things are true, if I'm only 17, then it's not even going to let me in the front door. So just to rehash that very explicitly, what went on as this code executed is it went up against the first clause, determined if that was true or not. If it was, it executed these statements, and then it actually moved on to whatever would be below this if statement, if in fact we had commands below this if statement. The rest of the clauses are not even evaluated. They're not even tested because we hit the first statement. Same thing is true when we hit the second statement, that elif statement. And we could have another elif right below this elif. When we hit that second statement, it said, hey, run these commands and then move on to the code below. It never ran, never tested the else statement. And of course, if neither of those things were true, then it got down to the else statement, ran that, and moved on to whatever code was below my if statement. So this is comparable to something called a switch or a case statement in a lot of other languages. In Python, you simply use an if and an elif in order to make a nice multiple catch if statement. So hopefully now you have a good idea for the logic behind the conditional statement in Python, the if then else statement in the Python language. That concludes this nugget on conditional statements, also known as if-then-else statements, in the Python programming language. Just to recap, we talked about expressions versus statements, and expressions being smaller portions of code that are reduced down or evaluated down to an individual value. For the purposes of this nugget, we were concerned with expressions that evaluate down to a true or a false value, also known as a Boolean value. Then we took at the logical operators that are used inside of those expressions that produce a Boolean result, and it's greater than, less than, equal to, not equal to. We wrote some code. We wrote an if block, and we saw how we could run a different statement depending on the input that the user keyed in. So if the user was 20 years old or older, then one statement ran, but if they weren't, then a different statement ran. And we took a look at how to build statement blocks inside of those if statements so that we could run multiple different lines of code depending on how our expressions evaluated. I hope this has been informative for you, and I'd like to thank you for viewing.